The simple cubic lattice is the simplest lattice structure and consists of 8 atoms at the 8 corners of a cube. In the ball and stick model shown here, the distances between the atoms are greatly exaggerated. In actuality, the atoms are packed much more closely together and touch somewhere in the structure. A more realistic model of this structure is the space-filling model. Here the size of the atoms is in correct proportion to the cell. This space-filling model demonstrates that in the case of the simple cubic lattice, the atoms touch along the edge of the cell. In the model shown here, each atom touches 3 others along the 3 edges of the cell. We can generate the unit cell of the simple cubic lattice by including only those portions of the atoms that appear inside the cell boundaries. In the case of the simple cubic cell, each atom lies 1/8 inside the cell. Since there are 8 of these fractional atoms, there is the equivalent of 1 atom inside the unit cell. The body-centered cubic lattice contains the same 8 vertex atoms as the simple cubic lattice, but with 1 body atom in the center of the cell. This simple change results in a structure that is completely different from the simple cubic lattice. Due to the atom at the center of the cell, the vertex atoms no longer touch along an edge of the cell in the space-filling model. Instead, each of the vertex atoms touches the center atom. The atoms are said to touch along the cube diagonal of the cell, which connects opposite corners of the cube. The unit cell for the body-centered cubic cell is shown here. In addition to the 8 vertex atoms, this cell contains 1 body atom that lies entirely inside the cell. This gives the equivalent of 2 atoms inside the cell. The face-centered cubic lattice contains the same 8 vertex atoms as in the simple cubic and body-centered cubic lattices, but also contains 6 atoms located in the 6 faces of the cell. In a space-filling model of the face-centered cubic unit cell, the atoms touch along the side diagonal of the cell. Each face atom touches the 4 vertex atoms that define the face of the cell. The unit cell of the face-centered cubic cell is shown here. The unit cell contains the same 8 vertex atoms as the simple cubic and body-centered cubic structures, each 1/8 inside the cell. The 6 face atoms each lie 1/2 inside the cell. When combined with the vertex atoms, this gives the equivalent of 4 atoms inside the cell. The term coordination number refers to the number of atoms touched by a given atom inside a lattice structure. We will consider the coordination number of the simple cubic lattice first. We have already seen that in the simple cubic lattice, the atoms touch along an edge of the cell. In a single unit cell, 1 vertex atom touches 3 other atoms along 3 edges of the cell. To see the remaining atoms, we must look outside a single cell. The same atom also touches 3 other atoms along the edges of 3 other cells for a coordination number of 6. The coordination number of the body-centered cubic cell is more obvious. Any body atom touches 8 vertex atoms for a coordination number of 8. The coordination number for a particular structure is the same regardless of which atom is chosen. Therefore, we can also say that each vertex atom is surrounded by 8 body atoms, again giving a coordination number of 8. Last, we will demonstrate the coordination number of the face-centered cubic cell. Recall that in the face-centered cube, the atoms touch along the side diagonal of the cell. Let us first consider the coordination number of a face atom. Recall that a face atom touches the 4 vertex atoms that define the face. Each face atom also touches 8 other face atoms, 4 above and 4 below, for a total coordination number of 12. Now let us consider the coordination number of a vertex atom. Each vertex atom touches 4 face atoms within the same plane, 4 face atoms below and 4 face atoms above, again giving a coordination number of 12. In addition to the 3 cubic structures previously discussed, there are 2 close-packed structures. Close-packed structures consist of close-packed layers of atoms within which each atom is surrounded by 6 others. The difference between the 2 close-packed structures lies with the way in which these layers are stacked. In no case do 2 close-packed layers lie on top of one another. Instead, each atom sits in a dimple formed by 3 atoms in the previous layer. We will use color to represent the layers. Here, each blue atom sits in a dimple formed by 3 green atoms in the previous layer. Imagine that a second layer of green atoms is added so that it is equivalent to the first layer of green atoms. Then, a second layer of blue atoms is added that is equivalent to the first layer of blue atoms. This alternating layering of close-packed layers generates a structure that is known as the hexagonal close-packed structure. A second layering scheme is as follows. The first 2 layers are the same as before, with each blue atom sitting in a dimple formed by 3 green atoms. In this case, however, the third layer is applied in such a way that it is not equivalent to the first. If this stacking pattern is repeated, with every third layer the same, this generates a structure known as the cubic close-packed structure. The second packing pattern is called cubic for a reason. The structure is equivalent to the face-centered cube. Here we use color to illustrate the close-packed layers within a face-centered cubic cell. Let's take a moment to review. The unit cell for the simple cubic structure contains the equivalent of 1 atom inside the cell. The atoms touch along an edge of the cell, and the coordination number is 6. The unit cell for the body-centered cubic structure contains the equivalent of 2 atoms inside the cell. The atoms touch along the cube diagonal of the cell, and the coordination number is 8. The unit cell for the face-centered cubic structure contains the equivalent of 4 atoms inside the cell. The atoms touch along the side diagonal of the cell, and the coordination number is 12. The hexagonal close-packed structure consists of close-packed layers of atoms stacked so that every other layer is identical. The cubic close-packed structure consists of close-packed layers of atoms stacked so that every third layer is identical. This structure is identical to the face-centered cube. It therefore has the same occupancy and coordination number.